Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss common ion effect on solubility of ionic salts. This is very important. Many questions is asked on this concept. Common ion effect on solubility of ionic salts. Last class I have discussed solubility equilibria of sparingly soluble salts. Also I discussed solubility product constant, and also discussed about the sparingly soluble salts. Now I am going to discuss common ion effect on solubility of ionic salts. How much salt will dissolve ionic salt, how common ion will affect on the solubility of ionic salts, that I am going to discuss. It is expected from Lee-Chatterjee principle that if we increase the concentration of any of the ions, it should combine with the ion of its opposite charge, and some of the salt will be precipitated till once again Ksp becomes equal to Qsp. Q means quotient. Okay, you know that at equilibrium both will be equal. That is a quotient, that is a Qsp. Qsp will be equal to Ksp only at equilibrium. And Qsp means, meaning of Qsp already told you, that if reactions are not at equilibrium, other than equilibrium, that time Q means quotient is used. Okay, it is similar to Ksp or K. Here we are using the solubility product. Sp means solubility product. Ksp means solubility product constant, and Qsp quotient solubility product. Then here, if in the reaction, when it is in equilibrium, ions are in equilibrium, then that time if any ion will be added from outside to the solution, then it will react with opposite ion present in the solution, and that will precipitate out. That salt formed in the solution will be precipitated out. But what you are adding, that must be common. As for example, barium sulfate Ba plus SO4 minus is there in the solution. Then if you add a sulfate ion from outside, then what will happen? That sulfate ion and barium ion both will react in the solution, and barium sulfate will precipitate out, because now they are not in equilibrium due to the sulfate ion which you have added from outside. Due to that, equilibrium disturbed. Now Q are in force. Q has increased, means concentration now increased. Hence, just to maintain the equilibrium, that barium sulfate will come out. It will precipitate. Like that way, you want to if you will add, suppose in barium ion you are adding from outside to the solution, then it will form barium ion plus sulfate ion present in water, and barium sulfate will precipitate out, because it became excess. Okay, then when excess means less or excess means Q will be applied. Okay, and when it is in equilibrium, then K will be applied. This is very important things I have told you. Then this Ksp is equal to Qsp. This is applicable even to soluble salts like sodium chloride. Okay, this KSP is equal to QSP. This will apply even to soluble salts like sodium chloride, except that due to higher concentration of the ions, we use their activities instead of their molarities in the expression for QSP. Same thing you will write if you are adding from the outside any concentration. Generally at equilibrium molarity we are using molarity, but if it will be I can say less or more, then we will use the term activity. Okay, this is important things. Thus, if we take a saturated solution of sodium chloride and pass HCl gas through it, in sodium chloride solution, if you will pass HCl gas through it, then sodium chloride is precipitated due to increased concentration, means activity of chloride ion will increase. Okay, due to increased concentration of chloride ion available from the dissociation of HCl. HCl you have passed, then Cl ion will increase in the solution, and Na is already present there in solution, then NaCl will be precipitated out. Sodium chloride thus obtained is of very high purity. Actually this is very can say useful. Common ion effect on solubility is very useful. To its use I am telling. First use that suppose sodium chloride solution is there, but in sodium chloride solution suppose some impurity was present. You have solution of sodium chloride. Someone told this is the sodium chloride solution, but impure sodium chloride solution. Maybe other things also present. Then if you will add in this situation, if you will add HCl, then what will happen? That now if you will add HCl, then chloride ion will increase. Then this chloride ion already it was there, NaCl. Cl was there, but now HCl you have passed. Then more chloride ion increased, more Cl ion increased. Then Na and Cl that will react and it will separate out. And this NaCl will be pure, not mixed, not impure. In the solution it was in impure form. Maybe other impurities may be present, but this Cl will react with only with Na, and it will form NaCl and it will precipitate out. This is very important things. You will get pure sodium chloride. Sodium chloride thus obtained is of very high purity, and we can get rid of impurities like sodium and magnesium. Sodium and magnesium sulfate may be there, but now you are getting pure sodium chloride. The common ion effect is also used, or almost you can say this second use I am talking about. The common ion effect is also used for almost complete precipitation of a particular ion as its aspiringly soluble salt with very low value of solubility product for gravimetric estimation. Means that solubility of AgCl means will be very less. Salty product of AgCl is very less. Then if you want silver ion, you know that suppose someone told this is a sodium AgCl solution. You have AgCl solution, but this is the AgCl, it is very less soluble. Then if you want Ag silver, then if you will pass same way, either NaCl solution or HCl solution, any solution if you will pass, then what will happen? Because Cl will be more. Cl will be more. Chloride ion, suppose you have passed. Then Cl increase, Cl concentration will increase. Then this Ag and Cl will react and AgCl will settle down. AgCl will precipitate out. Okay, because it is not soluble. But here because more Cl is there, you have passed a Cl. Then due to more concentration of Cl ion, Ag will react with this Cl ion and it will precipitate as a AgCl. Okay, then from that where it was very less soluble and now it was very difficult to separate out. Now you are getting it in the form of precipitation. You can filter it, then you will get silver chloride. Yes, silver is costlier. You know all the things. Then common ion effect is also used for almost complete precipitation of particular ion, as it's sparingly soluble salt with very low value of solubility product for gravimetric estimation. By gravimetric estimation also it can be precipitated, it can be separated, but that amount will be so less that it is very difficult to get the silver chloride or silver. And thus we can precipitate silver ion as silver chloride, and also it can be used for ferric ion. Ferric ion can be precipitated as ferric hydroxide. If will hydroxide ion, if will pass through the solution in ferric hydroxide solution, you want to separate ferric, then hydroxyl ion if you will pass in the form of NOH or potassium hydroxide in any way, then OH ion, due to the more OH ion concentration, ferric ion will precipitate out as a ferric hydroxide. Then ferric ion as its hydroxide or hydrated ferric oxide or hydrated ferric hydroxide, in the form of hydrated ferric oxide it will be separated out. Also barium ion can be separated as sulfate, as its sulfate, for quantitative estimation. How much it is dissolved in the solution, that is called estimation. How much it is there, correct amount also, that will precipitate out. Then in that precipitate, how much barium is there, you can calculate very easily, because barium sulfate molecule, barium atomic mass you are knowing, sulfate atomic mass you are knowing, then barium sulfate mass you could obviously, if you will add both atomic mass of barium, atomic mass of sulfate, then atomic mass of barium sulfate you will come to know. It is theoretical. Then in this molecular mass, how much barium ion is there, that you are knowing, correct? Then like that way, that in this amount, in what molecular mass of barium sulfate, in this molecular mass of barium sulfate, barium amount is this, you are knowing. Then what you got the precipitate, in that how much it is there, easily you can calculate for one, and then whatever x gram suppose you got precipitate, then in x gram how much, x gram maybe 10 gram, 15 gram, then in 15 gram how much barium is present, easily you can calculate, because in barium sulfate how much barium is there you are knowing. Then what you got in precipitate, that is also barium sulfate. Then for 1 gram how much present, barium is present, then for whatever you got precipitate, how much barium sulfate is, how much barium sulfate in that barium sulfate how much barium is present, easily you can calculate. Okay. Now again I am going to tell further. Actually this the solubility of salts of big acids, the solubility of salts of a big acid like phosphate, you can tell phosphate increases at lower pH. How will you prove this? This is the experimental, it happens, but you can prove it also. Okay, then this is a very conceptual. I will tell you how you can prove it. The solubility of salts of weak acid. Weak acid means what? Phosphoric acid is a weak acid. Phosphoric acid is a weak acid. HNO3 is a strong acid, HCl is a strong acid, H2SO4 is a strong acid. But phosphoric acid is a weak acid. They need salt, maybe sodium phosphate, potassium phosphate, whatever be calcium phosphate. Then these are the salts of weak acid like phosphoric acid. Then solubility of salts of weak acids like phosphates increases. Solubility increases at lower pH. Lower pH means what? More hydrogen ion concentration. More hydrogen ion concentration, lower pH means. Okay, don't forget. pH less means less than 7, means 6, 5, 4, 3. It means more acidic, more hydrogen ion concentration is there. 10 to the power minus 7 is the neutral. Then 10 to the power minus 6 is more than 10 to the power minus 7. Again 10 to the power minus 5 is more than 10 to the power minus 6. Like that, where 10 to the power minus 3, 10 to the power minus 2 are further more hydrogen ion concentration. Then obviously pH will be less. Both are reverse, inverse you can tell. Okay, pH is less means more acidic, hydrogen ion concentration is more. Same way, if a pH ion concentration is more, it means hydrogen is decreasing. Hydrogen ion concentration is less, OH ion concentration is increasing. Okay, reverse way, both are reverse. If pH value is less means acidic, pH value is more than 7 means basic. Okay, then now I am focusing on that. How will you tell that solubility of salts of weak acids increases at lower pH? How will you prove? Okay, then that I am telling you, because sometimes tough numericals will be asked on this concept. Then here this, how does it happen? Then this happens because at lower pH means more hydrogen concentration. It happens because at lower pH the concentration of the anion decreases. Concentration of anion like phosphate decreases. How it will decrease? The concentration of anion decreases due to protonation. Because more H ion is there, then it will cover entire phosphate. Then hydrogen ion will be more and phosphate will be less. That's why its concentration, anion concentration, decreases due to its protonation. This in turn increases the solubility of salt. Okay, this concentration decreases. Phosphate or anion, you can tell in general, its concentration decreases. This in turn increases the solubility. Okay, at equilibrium what will happen? Because now its concentration decreases, then again further it will undissociated salt will dissolve more and more to maintain the equilibrium. More undissociated salt will dissolve, means solubility increases. This is the reason I told you. Okay, and because this QW in this case, a QSP will become equal to KSP, because at equilibrium position KSP becomes QSP. That's why if we can say equilibrium will be disturbed, if we will add more things at equilibrium, then that time Q will be more, but quickly it will be readjusted, equilibrium will be readjusted. Then for that undissociated salt will dissolve more to maintain the ionic equilibrium. Okay. Then now this also you can tell we can satisfy also, we can satisfy two equilibria, because first equilibria is QSP. QSP is one equilibria and other equilibria is KSP. KSP. Then we have to satisfy both equilibria. Then see how you can satisfy both equilibria. Then we know that KSP in general we can tell salt is Mx, capital M, capital X, M plus, X minus. M plus is cation, X minus is anion. Mx is the salt. Then KSP is equal to molar concentration of X into molar concentration of X. Then this is the KSP. And other you can tell that HX means acid. HX means we are talking about the acid. HX in general. Then HX in solution, it will give H plus and X minus. Already you know. HX in solution will give H plus and X minus in solution. Then now K, you can write the these things equilibria. Ka you can write because HX is acid, hence Ka is equal to, how will you write? The general expression, hydrogen ion concentration, molar concentration of hydrogen ion into molar concentration of X ion divided by molar concentration of HX. Then cross multiplication if you will do, or don't do cross multiplication, only you have to separate it. You have to separate it. What separation? Then now you are knowing that Ka dissociation constant of acid is equal to molar concentration of hydrogen ion into molar concentration of anion, means X ion, divided by HX. Now you want Ka divided by H ion, only from this expression. Only from this expression you can get value of Ka divided by H ion. How will you get? Then express, just use, if you will see the expression quickly will understand. Ka is equal to molar concentration of H ion into molar concentration of X ion divided by molar concentration of HX. Then Ka divided by H ion is equal to what will remain? Then Ka divided H ion, just bring it down below the Ka. Then Ka divided by H ion will be equal to what is remaining now, means X minus divided by HX. Okay, only H ion you have brought down. Okay, cross multiplication. Then Ka divided by H ion, that is equal to what is remaining, means X minus divided by HX. Okay, this you got one relation. Okay, both Ka and H you have brought together. That's simple. In a left side you have brought H ion. Okay, then Ka divided by H plus, that is equal to what is left out, all the things like X minus divided by HX. Okay, then here you got one relation. Now just this relation, what you have to do, just you reverse it. Which is down, make it up you bring down both side. Then X upon HX will become now HX divided by X. HX divided by X. It was x divided by hx. Now it became hx divided by x. And right side Ka, dissociation constant K was up and H ion was down. Now reverse it. Then H ion will go up and K will come down. And both side you add +1, left side also, right side also. And after that you simplification. Okay, then you will get upside, you will get Hx plus x, molar concentration of x plus molar concentration of x divided by x minus means n ion. X is the n ion. And this side, right side, again you will simplify. They will get H ion concentration plus Ka divided by Ka. It is very easy. Okay, simplification you have done. Then you got this Hx plus H, Hx plus x minus means n ion divided by n ion means x minus. Okay, that is equal to H plus Ka divided by Ka. You got. Now again you can say reverse it. Because why you are doing like this? Because you are going to you will draw some conclusion. What I told in the beginning, that you want to prove it. That's why you are doing all the things. Then now this expression you reverse it both side. Then now x1 this x minus was down. Then now it will go upside. And upside was hx plus x. Then now down it will become hx plus x. Correct? And right side again same way. K was down, now K will go up, and H plus K was up, that will come down. Ka plus H came down. Then both are now equal. Both expression left side is equal to right side. And that is equal to, you consider F means factor. F means factor, small f. That is equal to F, you can consider. Then here actually you wanted to show the effect of hydrogen ion concentration. You wanted to show the effect of hydrogen ion concentration. Because you are talking about the pH. Then now H ion is down. H ion is down. Then and K is upside. K is upside. Okay. Then what will happen? It can be, by the expression it is clear, it can be seen that F decreases. Value of F decreases as the pH decreases. pH decreases means what? Hydrogen ion will increase. Then down hydrogen ion is there. Down hydrogen ion is there. And hydrogen ion decrease means hydrogen ion is more. pH decrease means hydrogen ion increases. Then hydrogen ion is in their expression down. Then obviously F value will be less. F value will be less. Less means solubility. What will happen? F value will be less. Then now what conclusion it will take? F decreases clearly because H ion concentration increases. Then F will decrease. Okay. F decreases as pH decreases. F decreases as pH decreases. If S is the solubility of the salt, if S is the solubility of the salt at a given pH, then what will happen? KSP is equal to S into Fs. S into Fs. Okay. F is the factor. Then Ksp is equal to S into Fs, means S square, S value we will put S into Fs. Then F value you know, F is equal to Ka divided by Ka plus H plus. Okay, that F value you have to put. Then S into Fs, and F value F you put, then it will become S into S square, and F value you have to put, means Ka divided by K plus H. Ka divided by Ka plus H. This was actually F you have considered. And when S square, Ksp is equal to S square into Ka divided by Ka plus H plus. Okay, then what will be the S value? Then S value will be under root this expression. Under root you can tell these things. Ksp is equal to S square. Ksp is equal to S square into Ka divided by K plus H. Then now this you want to know the S value. Then S square will be Ksp divided by Ka again divided by Ka plus H, means K plus will go upside and K will be down. K will be down, means Ksp into hydrogen ion concentration plus Ka divided by Ka. Very simple things. Just Kw means Ksp, not Kw. Ksp is equal to S square, and with S square one term is there. Suppose it is X. Then what will be the value of S? Then X will be Ksp divided by X. Ksp divided by X, that is S square. Then S is equal to under root Ksp divided by X. Correct? S is equal to under root Ksp divided by X. But you have considered X is equal to Ka divided by Ka plus H plus H ion. That value you put. That's simple. Then you will get the solubility. Then you will see also by the expression, you can see also the solubility S. The solubility S increases with increase in hydrogen ion concentration. Okay, because here you will see H ion is upside. H ion is upside. Then H ion will increase, means pH will decrease. H ion will increase, means pH will decrease. Hence, now you are going to prove that solubility increases. Solubility increases with increase in hydrogen concentration or decrease in pH. This actually the concept. Sometimes question is also asked, but it comes under the tough question. Then like that way you should know that this solubility of salts of big acids increases at a lower pH. This question is asked, multiple choice question. Okay, and if they will ask in a written exam, then you have to prove. But nowadays everywhere except this exam, CSIR net, there it is generally they will ask this type of question. It is tough. There he has to prove it. CSIR net exam. Okay. Then now I have discussed these things, common ion effect on solubility of ionic salts. Now I am going to discuss a few numericals, okay, based on this concept. Okay, then here some numericals I will tell you. You can easily solve it, and while solving numericals, concept will be also very clear. And now I am telling the problems. Okay, numericals. Then questions like that: calculate the solubility. Calculate the solubility of you can say A2X3. A2 capital A2X3 capital X. They have not given the name of salt. A2X3. Calculate the solubility of A2X3 in pure water, assuming that neither kind of ion reacts with water. The solubility product of A2X3, that is the Kw value, is given 1.1 into 10 to the power minus 23. That is the solubility product of A2X3. Solubility product of A2X3 is given 1.1 into 10 to the power minus 23. Actually, generally salt reacts with water. Then here they are told, don't consider that this ion of this salt will not react with water. Where they have clarified, no interaction with water. Only salt ion you consider. Okay. Then now you have to calculate solubility of this salt in water. Water is not interacting. Then how will you calculate? Then it is very easy to calculate. Very easy. A2X3. A2X3 means in water it will give it 2 cation, it will give, means 2A plus. 2 cation they will give and 3 anion will give. A2X3. It means 3X it will give and 2A will give. A is cation, X is anion, means negative charge. Then it will give. Here also you should understand how will you come to know what is the charge on cation and anion. How will you come to know? A2X3 is there. Then you can understand, okay, in solution it will give 2A plus 3X it will give. You understand that things. Because A2 means 2A it will give. X3 means 3X it will give. Means 2 moles cation will give and 3 mole anion will give. That you are understanding. But what will be the charge on cation and on anion? Then here, just to see opposite, A2X3, then this 3 is the positive charge for A. Okay, this is the valency. This is the valency of A. Opposite, cross, you can tell. A2X3, then X3, this 3 is for A. And A2, this 2 is for X. Means 2X3, A2X3. Then 2A it will give, and on A, 3 positive charge will be there. On an X, 2 negative charge will be there. Then now see, charge is balanced, neutral. Neutral because now A2X3, then on X has plus 3, then 2 into 3, 6 plus. And here 3X was there and 2 negative charge. Then 2 into 3, 6 negative charge. Then charge is neutral. Then now we understood how to know the you can say valency of both cation and anion. Because in solubility I told you that you have to consider charge also. Then now very easily you can get the solubility. Then suppose solubility is S mole per liter. Solubility of salt is S mole per liter, just suppose. But before solving numericals, you write the first reaction, general reaction, A2X3, that will give 2A 3 plus and 3X 2 minus. That you have to write. Okay. Then this is the balanced equation. First you write balanced equation, and whatever coefficient is there, that you have to write as a power. Don't forget that coefficient in a balanced equation, coefficient will go as a power of that cation and anion. And how many cation is there in water and how many anion is there in water, that is actually concentration. In this case, here 2 cation is there and 3 anion is there. Then 2 cation means concentration. 2A, that is the concentration, and 3X, that is again concentration of anion. Then now concentration of cation and anion, now you are knowing. Then now you are knowing KSP is equal to, here in a balanced equation it is the 2A plus 3X. Then what we will write? We will write A power 2 and X power 3. Correct? Then now you have to write concentration of A. The concentration of A is 2A. Then now it becomes 2A power 3. And now concentration of X is 3X. Then 3X power 3. Correct? 2A power 2, 3X power 3, because this 2A is the concentration of A and X, and 3X is the concentration for X. Then concentration value you have to write, and then already you have written the power. And after that you have to do solution. Okay, because now you have written 2A power 3 and 3X power 3. Then now KSP value is already given. KSP value in question already is given. Then now just you see here 2S you consider as a solubility. Then 2S power 2. It means S square. Correct? S square you got, and for this side 3 power 3 means 27. 3 into 3 into 3, 27. Then 27 and into 4. 27 into 4, because here 2 into 2, 4 was there. Then 27 into 4, it will come 108. And how many S? Then S square and S3, S7. No, S square, S3, S5, S square and S3, S5. Then now see KSP value is equal to 108 S power 5. Then what is the S5 is equal to what? Then KSP value divided by 108. S5 is equal to now KSP value divided by 108, and KSP value is given, that is 1.1 into 10 to the power minus 23. Then after the solving you will get the result. Okay, this is the S square value. Then S is equal to under root. Okay, then S value will get as a 1 into 0 into 10 to the power minus 5 mole per liter. 1 into 10 to the power minus 5 mole per liter. This is the answer. See how easy is this question. Now you can solve it very easily. Okay. Okay, in examination, medical, particularly medical or IIT means this type of question they are asking. Okay, because multiple choice question they will not give very tough. It will be easy, but if your concept is very clear, then quickly in mind you can solve it, and you should try to calculate only in mind. It is very good habit. Now second question I am going to discuss. The value of KSP of two aspiringly soluble salts, nickel hydroxide and silver cyanide, are 2 into 10 to the power minus 15 and 6 into 10 to the power minus 17 respectively. Which salt is more soluble? Explain it. Then they have given the value of solubility product of two aspiringly soluble salt. Then another example of aspiringly soluble salts is now nickel hydroxide, NiOH whole 2, NiOH whole 2, nickel hydroxide. And other example is silver cyanide. Okay, silver cyanide. Then both solubility they have given KSP, solubility product constant. For nickel hydroxide it is the 2 into 10 to the power minus 15, and for AgCN it is a 6 into 10 to the power minus 17. Then question is that which salt is more soluble? Explain. If they will ask which salt is more soluble, then by seeing the value you can tell. Nickel hydroxide is 10 to the power minus 15, and other is, and this AgCN value is 6 into 10 to the power minus 17. By seeing the power only you can tell whose KSP value is more, that is more soluble. Very simple things. Whose KSP value is more, they are more soluble. Then here you can see nickel hydroxide, its value is 10 to the power minus 15, and AgCN is AgCN is 10 to 6 into 10 to the minus 17, minus 17. Then minus 10 to the minus 15 is more. 10 to the power minus 15 is more than 10 to the power minus 17. Hence nickel hydroxide will dissolve more. Solubility is more for nickel hydroxide because its solubility product value is, you can say, more, 10 to the minus 15, and AgCN is minus 17. By seeing you can tell. But now question is that explain it. Explain it. Then how will you explain? That you understand. It is very easy to explain also. What I discussed the question now earlier, this is same type of explanation is there. You write the, I can say, reaction for both, for AgCN also and for nickel hydroxide also. Okay. So suppose in solution AgCN you will write Ag plus Cn minus, Ag silver ion plus cyanide ion you will write, and for nickel hydroxide you will write nickel nickel ion Ni2 plus 2OH minus, 2OH minus. Okay, this is the equation. Then Kw for AgCN is very simple. Kw is equal to molar concentration of silver ion into molar concentration of cyanide ion, and its value is given 6 into 10 to the power minus 17. Okay, and for nickel hydroxide its value is 2 into 10 to the power minus 15. Then suppose silver ion concentration is S1, solubility or concentration we can tell silver ion concentration is S1, and cyanide ion is AgCN is there. Suppose silver ion is S1, then obviously both are the same number, Ag into Cn, then both are S1 into S1, then KSP is equal to S square. KSP for AgCN is equal to, for AgS, again Cn also S1 square. And same way for here KSP for nickel hydroxide, nickel is suppose S2. Then here cyanide is OH and nickel hydroxide is there. The nickel is S2 you have considered. Then OH ion will be 2S2 because it is giving 2 OH ion. Then 2S2. S2 into 2S2. S2 into 2S2. This is the molecular concentration. Then S2 into S2 down, simply S1, S2 we are writing the same way. Then S2 into 2S2 means 2S square. 2S square to S2 square you can write. S1, S2 just only to differentiate you are writing 1 and 2 for the two salt. Then it became S2 into 2S2. Then here you will get how much total? Then you will get here this things S2 into 2S2 means 2S square to S2 square, and its KW value KSP value is given. KS value is given for nickel hydroxide. Okay, then it means that is value is given 7.8 into 10 to the power how much 17 or 6 into 10 to the power minus 17, that is equal to 6 into 10 to the power minus 17, that is for this thing silver cyanide, that is a S1 square. What you consider S1 square means S1 square is equal to 6 into 10 to the power minus 17. Then S1 will be under root 6 into 10 to the power minus 17, that is equal to 7.8 into 10 to the power minus 9, 10 to the power minus 9, 7.8 into 10 to the power minus 9. And here what you got? S2 into 2S2 square, S2 into 2S2 square, because in balanced equation for the nickel hydroxide you are writing Ni plus 2OH. Then just you will write, because coefficient is 2, it means it will go power 2. Okay, and first one only 1 is there, hence it will go as a 1 only. Then S1 concentration is only S1 only, but here 2S2 and not S2. For S2 only concentration is S2, but for second OH ion 2S2 is concentration. Then in the you will write 2S2 square, then S2 into 2S2 square, that is equal to it is given value 2 into 10 to the power minus 15 for nickel hydroxide I am talking about. Then here that you will get S2 into 2S2 square means 2 into 2 4 you will get S2 power 3, 4S3 means S2 3, 4S2 power 3. Then now what is the value of, you can say S3 S cube means then S3 is equal to that it will be divided by 4. It will be divided by 4. Whatever KSP values they have given for nickel hydroxide, KSP divided by 4. Okay. Then this is the value of S2 cube you can tell. Then what is the value of 1S2? Only S2. Then now KSP value divided by 4 power 1 upon 3. Then you will get value, S2 value will get 0.58 into 10 to the power minus 4. This is the S2 value for nickel hydroxide, which is more than silver cyanide, because its value was 10 to the power minus 9, 7.8 10 to the power minus 9. this is less than 0.58 into 10 to the power minus 4. Minus 4 is more. It means nickel hydroxide, that will solubility of neutral this hydroxide is more, nickel hydroxide is more than silver cyanide. This I have discussed the, you can say, numericals. Last numerical is there, one more, that also I will discuss. Question I am reading. Calculate the molar solubility of nickel hydroxide in 0.10 m NOH solution. The ionic product of nickel hydroxide is given 2 into 10 to the power minus 15. Okay, minus 15. What I discussed, same value is there. 2 into 10 to the power minus 15. This is the ionic product of nickel hydroxide. Then your question is that you have to calculate solubility, molar solubility of nickel hydroxide. But nickel hydroxide now it is dissolved in sodium hydroxide. Sodium hydroxide solution is there, in that nickel hydroxide you have added. Then sodium hydroxide concentration was 0.10 m. 0.1 you can tell. 0.1 m means 1 upon 10. 0.1 m NOH solution was there, in that you have added nickel hydroxide. Then obviously now hydroxyl ion concentration will increase. That you have to count, that you have to consider, because OH ion concentration increased. This is the only important things. It means now total hydrogen OH ion concentration will be what? 2s. This was due to the nickel hydroxide. 2s, and for this, and for these things, KOH it is 0.10. Okay, thus total concentration will be, you can say, 2s plus 0.10. 2s plus 0.10, because this 0.10 you have to consider for NOH. NOH is also giving OH ion. Then total OH ion concentration is now becoming 0.10 plus 2s. But here you should know that Kw is very small. 10 to the power minus 15 is small. Hence, in comparison to 2s, 0.10 is very less. Hence, you can neglect it. Hence, you can write for 0.10 plus 2s, that is you can write 0.10 means 2s, solubility will be less. Hence s you can neglect, 2s value you can neglect. Okay, because its solubility will be, it is a springly soluble salt. Then with this value in comparison to 0.1, 2s value is very less, hence you can neglect. Then this 0.10 plus 2s, that you can write only 0.10, 2s you have neglected. Then now what will this solubility product value of nickel hydroxide is already given, 2 into 10 to the power minus 15, that is equal to nickel you have considered S, solubility is S, then S into, for nickel S, solubility you have considered S, then S value will come to know, then S into, because nickel hydroxide NiOH whole 2. Okay, then for OH that is the 0.10, OH concentration will be 0.10 power 2, because in formula nickel plus 2OH, then power will go as 2 will go as a power. Then for nickel S into OH ion concentration power 2, then OH ion concentration is now 0.1. Total OH now it became 0.1 because you have neglected 2s value. Then this S into 0.1, 0.10 power 2. That's simple. Then now ionic Ksp value you are knowing. Ksp is equal to S into 0.1 power 2 or 0.10 power 2. Hence, what is the S value? Then S is equal to Ksp value divided by 0.1 square. Ksp value divided by 0.1 square. That is the S value. Hence, after putting the value and solving, you will get the you can say value I like, you will get 2 into 10 to the power minus 2 into 10 to the power minus 13. Okay, then this is the value of means S value you got, that is the nickel solubility of nickel value you got 2 to the 2 into 10 to the power minus 13 value you will get. Okay, after solving whatever you get, that is the solubility for nickel ion. Okay, it is very easy. Only OH ion you have to consider, and that also OH ion you have to neglect it in comparison to 0.10. After that, S into OH power 2 was there. OH concentration is now total concentration is 0.10. Then S into 0.1 S into 0.1 square, that is equal to Ksp value. Then S is equal to Ksp divided by 0.1 square. Whatever will come, Ksp value is given. Okay, you put the value and get the result. Very easy. Then now entire you can say this part 1 full chapter, 7 chapter was there, finished. This chapter it was actually big chapter. I have chemical equilibrium, actually it was very big chapter. I have finished. It was including actually small chapter also. Main chapter was chemical equilibrium. In that acid base salt, solubility product, common ion effect, all things were present. That's why it became big, and this was actually necessary also because all exist in the ionic form. That's why they have it is included in the one chapter only. So now this chapter finished, chemical equilibrium chapter finished, and total part 1 100% finished. For 11th actually fully finished part 1. Part 2 I will start, and in this part 1, that is for medical, those who are preparing for medical and IIT mains and advanced, many questions will be asked. I think almost all questions will directly or indirectly will be asked. You will be able to answer. Okay, question they can frame different, but all answer you will get only from this, from the part 1. Whatever question they will ask, I think till date I have seen all questions are asking in indirect way, not directly. For the 11th directly they will ask for their exam, but for the IIT advanced or main they will ask in indirect way, and you will be able to know you will be able to answer the question, because now concept you are knowing. All questions they are asking based on concept. Okay, then now I am stopping only here, and next class I will come with new chapter part 2. Okay, thank you.